Okay, so are there any questions about the first part?
Yeah, so if we don't give an explanation or a thorough explanation why, but we do get the correct answer, like if we say it's not injective, but we don't give an explanation why, do we get any partial credit, or is it just all or nothing?
You would get partial credit, but
So if we just say non-injective and leave no answer, no response why, we still get partial credit. Okay.
yeah, so you do get partial credit if you just answer it, but it's not going to be a whole lot.
I understand.
Because the idea is, I need to understand your reasoning. Yep.
And I was going to wonder, like, because in this one it said at least two. What's something if we say one element? Would it be wrong?
It would be wrong.
Okay,
Because if one element indeed maps to, well, you cannot say the same anymore. If it's one single element, you cannot compare. And okay, do you guys have any questions back there? Yep.
So like for subjectiveness,
Uh-huh.
like could be or might not be, like, do we have to say that as well, or do we not?
If you cannot confirm and say, regardless of how the function is defined and regardless of what is in D and what is in E, it has to be this property, then you don't mention it. So we'll get to the next one. Okay. Okay. Is injectiveness okay so far? Okay. But you cannot say anything about surjectiveness. So you just don't say. So that's why I said if you do not mention surjective and you do not mention not surjective, then that is actually the correct answer in this case, because you cannot confirm one way or another whether it is surjective or not. Yep.
So what I was saying is that the reason why you have to say at least two is because you have to say one is in the domain and one in the codomain.
No.
Oh.
It's two elements. Okay, read this carefully.
Right.
Two elements in D. So both of those are in D, but they are different elements. If they map to the same thing in E, then it is not injective.
All right, yeah, that's what I was. Okay, cool.
Okay. But we cannot make any type of implication whether it is surjective or not surjective. It can be surjective. It may not be surjective, since we cannot know for sure, so we don't say anything about surjectiveness. Yep.
I'm just kind of assuming that you don't care if we write it in a sentence or if we write it in a quotation.
That is correct. So you can use full sentence, you can use points, or you can just use symbols when it is applicable. As long as I understand your answer, it's fine. Okay, but it has to be as long as I understand the question. I mean your answer without you explaining to me after the exam. In other words, people cannot just kind of squiggle and say, but this is the right answer. I cannot understand that part. Let me explain it to you. This means, yep.
Could you also say on number one that it is not bijective because it is not injective at the end of it?
Yeah, because bijectiveness requires that it is both injective and surjective. We know for sure it's not injective, so there's no way it can be bijective. So that's a good point. Yep.
But in this case, we don't have to say anything about bijectiveness because it's implied at this point.
Well, but that's based on the assumption that how bijectiveness is defined.
So you're assuming we don't know, so we do have to talk about bijectiveness.
Yeah.
Okay.
So it'd be helpful if you just mentioned
This
that.
answer isn't fully correct.
This answer isn't correct, yeah.
So this answer is incomplete. It is not wrong. It is just incomplete because I did not mention that it is also confirmed that it is not bijective.
So what would you give this answer?
Huh?
What would you give yourself?
Yeah, what would you give?
This would be a B, so it would be kind of like a B type answer because it's almost right. I demonstrated, I understand the reasoning, but it is not entirely complete. So that would be a B type answer. In other words, whatever point value I allocate to this part, I'll get 75% of that. Yep.
Is there a symbol for injective, surjective, and bijective?
I do not know of any.
Oh, snap.
So just spell it out. Yeah, but I don't use those terms in this class, so try not to use those terms. Yeah. Okay, so the second part is if I know for sure that the cardinality of E is greater than the cardinality of D, what can we conclude for sure? It cannot be surjective because there has to be some elements in E that is not mapped to from D. Okay, So the rationale is about the same, but you can also then confirm that it cannot be bijective, because anything that is not surjective automatically cannot be bijective. Okay, number three. Number three is has D equals to E. What can you conclude for certain and why? So as it turns out, there are certain things that we can still confirm. So this is the really, really kind of tricky part. So part three is the worst part of this question. Is there are still things you can tell. Even though, if you just look at this and go like, okay, the cardinalities are the same, so what can we possibly say? Because it can be injective, it may not be injective, it can be surjective, it may not be injective. But what we also know for sure is it cannot be not injective but surjective. In other words, if it is injective, it has to be surjective. If it is not injective, it has to be not surjective. So they can only, one has to imply the other. Okay? So that is the tricky part. Even though you cannot really conclude whether F is bijective or not, okay, you still have to mention this, because this is also something that we know for sure. Yep.
What's up if the codomain and domain was switched, like if E equal D, would it matter?
What? Say again?
Like, let's say if E and D was switched over, would it really matter? Or?
How do you switch it? In the equality?
Well, no, I'm just saying, you see how you have if D equals E, I was just wondering if you replace if E equals D, if you would.
If the cardinality of E equals the cardinality of D?
Right.
Okay, so here's the question. Is equality commutative?
Yes.
Okay.
There you go. Okay.
Just confirming that.
All right. So the last one is, what if we know that the cardinalities of the two sets are not the same? So the only thing you know for sure is it is not bijective. But other than that, there's nothing you can conclude here. Is that okay? All right. So here we are moving on to question number 2. So question number 2 is asking, given that function f is mapping the set 1, 2, 3 to the set ABC, and function g, another function, is also mapping the same domain 1, 2, 3 to the same codomain ABC, are both bijective. Okay, so we are claiming that f and g are both functions, they're both bijective. Come up with an example, and you have to spell out how elements are, constructed in both functions, such that f minus g is 1a, 2b. If you think this is impossible, you have to explain why that is the case. So let's not read the answer, because the rest is actually the answer. What do you think? If I tell you, yeah, go ahead.
Well, as long as they're mapped to different elements, like if one is mapped to B from the F, and then one is mapped to C and G.
Okay. So, but how would you start, with answering this question? Because the answer has to be the spelled out version of F and G. Yep.
I'd include 1 and A, 2 and B and F.
Yep. So the one thing you know for sure is F is going to have 1A, 2B, and G cannot have 1A, 2B. Okay, so that's the one thing we know for sure, because F minus G consists of all the elements that are in F but not in G. Okay? What about, okay, so if F has for sure 1A, 2B, what is the third element that has to be in F? Must be 3C. How do we know it's 3C and not 3A or 3B? Because it's bijective. Yep. So after we eliminate, and say, okay, we have already mapped to the other two elements in the codomain, 3 has to map to the only remaining element in the codomain. Okay. So can 3C be in G? It has to be, right? Because if it is not, then we have a problem, because F minus G would be different from what it is now. So we know the common element between F and G is 3C. We also know in G we cannot have 1A, 2B, but yet we also know G itself is also bijective. So what do we need to do? Switch them around. So G is going to have 1B and 2A. Yep. So that concludes how we work out the composition of each function by what is given to us. Is that okay? All right. How many people have taken the IQ test, or an IQ test?
No, the internet ones are pretty bad.
But this is kind of resembling some of the IQ tests because it's basically having you to kind of logically deduce what can and what cannot be the case, and then you limit all the options down to a particular possibility. Okay, question number. Oh, I got an empty page here. Question number 3. The notation of being a function m mapping x to y was wrong. In the future, okay, so that's note to myself, how I was using the wrong notation. Okay. Assuming f is this particular set. So f is actually a set of 2 tuples. x1 is one element, y2 is one element, z3 is another element. We also know that f is a subset of x times y, okay, the Cartesian product between x and y. Answer each one of the following parts by defining x and y given the properties as described. And if it is not possible, tell me it's not possible and explain why it is not possible. Okay. So the first one is I fixed the notate. Well, okay, these notations are wrong. Okay, so that's what I was reminding myself was this is the wrong notation, because the notation is supposed to have a colon here, and turn that to an arrow here. So that's why I was reminding myself that my notation was wrong. Okay, so let me just kind of fix all of this stuff first. And one more. There we go. So now I fixed all the notations. Okay. So I want you to tell me what can be x and y, given that f is not a function in this case. So for part 1, I'm saying that f is a set of 2 tuples, but it is not a function. Okay. So how can you define x and y such that f is not a function? Well, there are 2 ways to make something not a function. Okay. One is certain things in the domain, at least one thing in the domain is not mapped at all. So I'm just doing that here. I'm just putting one extra thing in the domain that is not mapped. I can choose anything here. I can choose W, okay, if I want to, but an empty set would work too, even though it's kind of weird. Weird is not wrong. It's just not what most people would think of. Okay. But I also need to define what y is, right? So if x has an extra element, y can be just 1, 2, and 3. It doesn't need anything else. So y can be just 1, 2, and 3, and f would still not be a function, because the problem of f not being a function has nothing to do with the codomain. It has to do with the domain itself. Is that okay? So that means if your answer is just this, it is correct. Okay? And this empty set here doesn't have to be the empty set. It can be W, it can be Miata, it can be MX5, it can be MR2, it can be TAC.
Can it be alpha null?
Can be alpha null. It can even be this, okay? If you really want to make it confusing to yourself, it can even be that if you want to. Because the set XYZ can be an element of X, right? But it is not mapped in the set, F, so.
Well, you put like capital X in there, right?
You cannot put capital X in it because, then it is,
right.
cannot be itself. Yep.
Could it be a set of the set of it, capital X?
Say that one more time.
Could it have a set of the set of capital X?
No. Yeah, because you cannot nest the set itself anyway into its own elements. Okay, number 2. So number 2 is, what if f is a function it is injective, but it is not surjective. Okay, so in order for x to be a function, I need to make sure that everything that is mapped in the set F are in fact in the set X, which is our domain. Okay, but we don't want it to be surjective. Okay, we want to make sure that it is not surjective. So to make sure it is not surjective, we look at everything that is mapped in Y, and then we just go like, well, we'll just add one more thing that is not mapped in.
Well, we only got 3 up there. How do we get to 4?
Hmm?
How did we get 4?
It can be anything other than 1, 2, and 3.
Oh, okay. So it can be Volkswagen?
Can be Volkswagen, yes.
So if the original f equals it was x1, y3, z3,
Uh-huh.
could we just put that it's not possible?
Yeah.
For it to be, okay.
Yeah, I think there's one
Oh,
case
right.
here that is not possible. Let's keep on going. The next one is probably not possible. So the next one says, define x and y so that f is a function. It is surjective but not injective. So how can we make f surjective but not injective?
Oh, let's see. Let's see.
Color has to be smaller, but you can't do that with given.
Well, because you're already given what f is as a set, right? So in order for it to be surjective, we have to make sure that everything is already mapped to in the codomain. So that means that y has to be x, y, z, right? If y has to be x, y, z, then what about x? Well, x has to be, y has to be, sorry, excuse me, y has to be 1, 2, 3 in order for this to be surjective. Okay? That is not a problem. But because f is a function, that locks down that x has to be just lowercase x, y, and z. So now f is automatically bijective because it is automatically injective as well. So that's why it's not possible. The last one is also impossible because it is asking how can we make f not surjective and not injective.
Wait, how can we do that? So like, well, like how are we writing just saying possible?
Well, why is it not possible? Because f is a function. Okay. Now f being a function means x, y, z lowercase is x. Okay, so that locks it down already, right? We cannot have any further elements in uppercase x. All right. But not being surjective means y has to have some extra step. But the problem is f being a function means it is automatically injective because of the way we define the elements in f. So we don't even have to touch on the not surjective part. Just saying that it is not injective is already impossible.
So if we're answering these, can we just write impossible because that doesn't be injective, or do we try to like show, like try to and be like, oh, we can't answer that?
If it were injective, so you have to say if because f is a function, then you have to explain why knowing f is a function and the way it's defined
so
here
basically explain it.
implies it is already injective. So that means it is not possible to make it not
Okay, so
injective.
we can't just write impossible because that has to be injective, or like can we just write like impossible because that has to be injective, or do we need to explain it, right?
Yep.
So we try, okay.
So would you consider the 3 and 4 wrong? If we
That's
wrote it like
kind of-
that, it would be wrong. Like impossible because that has to be injective, and if we left x and y like empty, would we like take credit for that?
Well, this is actually correct, okay? Because it does say that f has to be injective. Because there are many ways why it is not possible. Because you can claim that it is not possible because we know that this is guaranteed not surjective, but that's not the reason why we can say this is not possible. The reason why f cannot fit this requirement is only because it is injective. It has to be injective, so it is not possible. Is that okay?
All right. So moving. Yeah.
Yeah, on number 4, you're missing a word in the answer.
To be, right? Well, missing the be. Fine. Here's your B. Or I can paste the bitmap of an actual B. There's a symbol right there.
Okay. So question number 4. Question number 4 is about alphanol. So I'm not. We are not going to have alphanol in our exam because we have actually concluded that. So yes, okay. So alphanol is going to be in the test.
Really? Come on, man.
I still want this exam.
Okay, so in this case, okay, let me get rid of the answer first, okay, and then we'll try to figure out, how we get to the answer. So in this case, we have G defined the same way as in the notes. Okay, so this means it is important to bring the notes with you because that contains the definition of how we map from a 2-dimensional space to a 1-dimensional space. So it's the same as we discussed in class. So we're going to define a new function. The new function is called H. It is going to map 3 dimensions into 1 single dimension. And then I give you examples. So in this case, I give you the example of the 3D coordinate 165 is mapped to the natural number 428. So I want you to find the proper definition of H, which is going to make use of G. So your answer should look like something like this. The H of the 3D coordinate XYZ. This is just an example, okay? It doesn't mean that yours is going to look like this. Most likely it does not, right? But it is going to be the application of G in a nested way. Is that okay? All right. So the question is, how is G, the application of G, nested in this specific case? That is the question. Is that okay? So how do you figure this one out? I mean, what are you given with? Okay, that is how you get started thinking about the solution. Is once again go through what are the clues given to you, and you always start with the clues and what you already have on your notes and stuff like that.
You're given with X, Y, Z, or?
Sorry?
You're given with X, Y, Z, or?
You are given a single example, right? You're given one single example. 165 as a 3D coordinate is mapped to 428. We also know that H itself is the nested application of G in some arrangement that we do not yet know of. Okay? So now the question is, how are we nesting the application of G inside H? That is the question. So what is the first step you're going to take to help answer this question? How do you isolate the last one first? Okay, so this is all going in one direction. Is it possible to go in a backward direction? In other words, the question is, okay, I'm going to use equation here. Okay, there we go. So the question is, can you apply G inverse to 428? And if you do, how is that going to help you answer this question? That is the question. Okay. So let's go ahead and apply the inverse first. And of course, I cannot remember my own stuff.
Of course.
That's why I wrote it, right?
Yes, I know, man.
The whole reason of writing is so that I can remember it.
Yeah, I was to say,
All right. So we get to the definition of the inverse function, which starts with a W, right? So we have to start with W of n first. Oops. I think did I just go past it? Yep, I did. Nope, I did not. That's W right there. And there we go. So this is just another way to define W. It looks a little bit different from the way we did it in class, but it's another way. So we just work out this one. So we basically say W of 428 is, yep,
So could we literally just copy it directly out of the notes and say from notes?
Yeah.
Next to it? Okay.
yeah, it's, yeah. Or you can just, you can even jump the steps and just say the inverse of G applied to 428, give us, this particular answer. But I'm just working this out here step by step. So we have 8n, okay, so we have 8 times 428 plus 1, the whole thing taking the square root of, and then minus 1, and then the whole thing divided by 2. Okay, can someone work this out for me?
I got 28.7617.
Okay, so when we take the floor of this, what is that?
28.
28? Okay. So if we know that Wn is 28, then we know what x and y would be. Because this is the inverse function. So the inverse function, according to the whiteboard, is saying, okay, so it's 28 times 31, the whole thing divided by 2, minus 428. That is going to be our x. And then the other one is y, which is 428, which is n, minus 28 times 29, the whole thing divided by 2. So what is x and what is y in this case?
X is negative 34.5.
Should not be negative.
What?
X should not be negative unless I did some.
28 times 20%. Let's see the parentheses.
Okay, let me do this math here. Okay, so we have 28 times 31,
I got 6.
the whole thing divided by 2, minus 428. Yeah, we get 6. So x is 6. And once we know this is 6, the other one is going to be 22. So y is going to be 22. Because when you add these up, they should be the w. Okay? Okay, so we get the answer of so the answer is G inverse of 428 is the coordinate, the two-dimensional coordinate of 622. Is that okay? How is that going to help us with answering that question? We don't have to, well, we have to do it again to resolve the 22. But without doing it even again, let me find out where the question is. There we go. Okay. So we now know that this is just 622. Okay. And do we see a 6 here? 165 is mapped to 428, right? Okay. Question?
No, I was just trying to find that because I don't want to do any outside research. I'm trying to see is it co-inverse functions is what we're doing here. I'm just trying to get the name of it.
Okay. Yep.
Actually, I'll wait till you don't answer the exam. It's a different question. I'll wait.
Okay. So from here, what we can now infer is the 6, which is the y coordinate here, is pulled out first on its own. Okay, so if I were to write this one, I'm going to say insert equation. Oh, I chose the wrong thing. Okay, one more time. Insert equation. There we go. Okay, so G inverse of n. Okay, we know that we are extracting the y first. Okay, but now we still have a question of what is the other thing? Okay, so we have a question here. What goes here? Okay, so now we have to find the inverse of 22. So we basically apply that one more time. So this time we apply G inverse to 22. So when you apply that to 22, we just redo the math, figure out W first, and then plug it in. So we just have to change this number, change that number. So we got 22 and 22 here. So what is the result of this calculation? So we have 176, 177. What is the square root of 177? 177 square root is, sorry? A little less than 14? So it's 13 and something.
13.3.
I got 6.
Okay, and what about the entire thing?
So 6.
Hmm?
So 6.15 again.
6? Okay.
Yeah, that'd be like 4.
So this entire thing is 6. Okay. So knowing this is 6, we know how to get to the x coordinate, because the x coordinate is 6 times 9, the whole thing divided by 2 minus 22, that's our x, and then the y is 6 times 7, the whole thing divided by 2, and then 22 minus that. Okay, so this is 3, 3, 9 is 27, 27 minus 22 is 5, and the other one has to be a 1. Because when you add these two up, they should be 6. Okay? Alright. So, getting back to...
Question.
Yep.
Where does 9 and 7 come from?
Say that one more
22
time.
divided 9 and 7?
The 9 and 7?
Yeah. What's 6 times 9? Where does that 9?
6 times 9, because this is supposed to be w plus 3. This is supposed to be w plus 1. And the 6 is w itself. Okay. So we got 5 and 1 here. Okay. So knowing this, okay, so knowing that this 22 is broken up into 5, 1, as the word does, and we also know where the 5 comes from. The 5 is the z, the 1 is the x. Right? So now we can now make the conclusion and say h of xyz is the g of, let's see, we have to reverse the whole process. The last one, is this one first. So the 6 is pulled out first, the 6 is the y, and then we apply g again, but this time we apply g to 5, 1. 5 is the z, and 1 is the x. So that would be the answer in bold. But that's how we kind of reverse the whole process, is we apply G inverse to break out the numbers. Yep. Huh? The parentheses for the coordinates. Yep. So we need one here, and then another pair here.
And then one on the H. On the H.
Whoops. Press the wrong key. There you go. But are you guys following the steps? How I kind of went back, apply the inverse function and then figure out, okay, the 6 is coming from here, and then the 22 has to come from the other two numbers, and then I have to figure out what is G inverse of 22 to figure out, what coordinate gives me 22. And then we figure out the 5 is coming from the z, the 1 is coming from the x. So that's how we can figure out how the g functions are nested.
And all this is called inverse function, right?
G inverse is the inverse function of g. Yep.
Could you control Z to the answer that was on there before this? Does it seem more thorough?
Oh, that's a long way. Pretty sure there's a way to do it from all the way from the undo menu. Nope, doesn't have the history of all the undos.
Somebody
Just hold Control Z.
Just hold on Control Z.
You just hold it.
No one to let go.
There it is.
Okay, there we go.
Oh, there it is.
But I'm missing the B again. There we go. There you go. By the way, you can always make a copy of this document into your own Google document. So if you make a copy, then you're basically taking a snapshot of the document and the way it is right now. So I can continue to do editing, but you always have that snapshot. Is that okay? Yep.
Can we bring a printout copy of the practice test to the test?
Absolutely.
Oh, so we can
You can bring as far back in time as you can possibly find out. You can bring all of those past tests with you as well.
Except that we have less desk space.
You only have so much desk space.
The last
That is
class was
correct.
9. We had 9.
But you can flip, right?
Yeah, I had the battle station for this fight.
Battle station. Okay. Any questions? I thought I saw her hand earlier. Yep. This is already on the shared drive right now, as it is. Yep. But if you don't want me to make any further changes and you just want this version, you can now make a copy of this into your own Google Drive. So it makes a snapshot of this document, the way it is right now. All right. So that's question number 4. Any other questions about number 4? Yep.
Is it possible that there could be an error? For example, we're estimating that from the square root we're getting the floor.
Okay.
Number.
So if you make an error, then you will not find those 3 numbers again. So that means something is amiss.
It's mostly we get this because it's the floor function.
Say again?
We get these numbers because it is the floor function.
Yes. Yep.
Yeah.
All right. So are we okay so far with number 4? Okay. If number 4 is okay, we move on to number 5. Okay. So number 5 is related to number 4 because it's also one of those application of G. So right here, okay, this is my note to self, based on student feedback. Confusion of whether multiplication can be used in the derivation. Okay, so let's read the question first. Assume G is the same function that we defined that we actually make use of in question number 4. Let P equals to G of the coordinate of x0, y0 for some coordinate, x0, y0. Without even evaluating the entire G function, I want you to express the value of G of x0 but y0 plus 1 in terms of P, x0, and y0. And in this case, P is defined. You can use addition and subtraction, but not division or multiplication in the final form. But in the derivation, you can use multiplication. So you can use multiplication and division and stuff like that in the derivation, but in the end, I want you to express it without using multiplication or division. You can introduce constants like 1 and 2, any number of constants you can just introduce, and I want you to show the derivation. So P is defined in a particular way. P is really just the G function applied to the original coordinate, which is x0, y0. I want you to express the G value of x0, y0 plus 1 in terms of P, x0, y0, and whatever constant you want to use. Okay, so now the question is, how do you do it? What would be your steps in doing this?
Okay.
So I did all the derivations here, but you need to understand how I did it, okay? Because you basically have to apply G to the whole thing first, okay? You have to expand the whole thing and see what it looks like. And that's why in the steps, it's not possible to avoid using multiplication or division, because when you expand G, it involves multiplication and division. So how did I go from the first line to the second line? This is algebra.
Grouping.
Okay, grouping, because I group x, y to just x plus y, its own group. I group x, y into its own group, x, y here. Is that okay?
I guess so.
And then what did I do in the next one?
Simplify the right parenthesis in the numerator plus 2.
Okay.
Oh my god.
It is factoring, right?
Yeah, I get.
It's quite the step.
So you can spot the 2 kind of on its own here.
Yeah.
So this 2 is really the same thing as this 2.
Right.
And then the x plus y is the other factor. So that's how I broke it out. Okay. What did I do from the 4th row to the 5th row? Right? Just split it up. So this half goes to one side, this half goes to the other side. Okay. What about from here to here? I just reposition things a little bit. Okay. What about from here to here?
You recognize.
There are several things, right? 2 things that I did. One is to recognize x plus y plus 1 times x plus y, the whole thing divided by 2 plus y is really just g of xy. And then the other side is to do the simplification. 2 divided by 2 is 1, it just disappears. So now I get x plus y plus 1 plus, this plus y is already on the other side, and then plus 1 on the outside. Okay, so 1 plus 1 is just a 2, and then we just get p plus x plus y plus 2. So the significance of this particular thing is basically saying if you know the value of a particular pixel, okay, the pixel right on top of it, this one, the value of that pixel on top is really the value of the pixel, the original pixel, plus x plus y plus 2. But why is that useful? It only involves the use of addition. It does not involve the use of multiplication or division. But why is that significant? Why do we care? Yep. Addition is fast on just about any processor, including the inexpensive processors. Multiplication and division can be expensive if they are not supported as built-in instructions. So that's why if you can avoid the use of multiplication and division, the math goes a lot faster. But then the restriction is, but I can only figure out the value of the pixel that is adjacent to the one that we are dealing with. What are the chances that we want to do something like that? What do you think? When you need to draw a straight line, they are always, almost always, next to each other. Okay, it can be next to each other horizontally or next to each other vertically, but you're not going to jump to some random pixels. So this means if you need to use this method to plot a line, but you're not actually outputting the pixel, but you're outputting the value corresponding to the pixels, it gives you a really fast way of doing it. Is that okay? But why is that important?
As long as
Why do we want to squeeze as much performance out of really low-end processors as possible?
Backward compatibility?
Hmm?
Backward compatibility?
Backward compatibility is one. Go ahead.
More FPS.
More FPS. That is correct.
Oh, wait.
So for those of you who, I think the majority of this class, is kind of grew up in an era where you don't have to deal with something like this. So I'm going to show you this Apple II. This is back in the good old days, when we have the Apple II computers.
Yes.
Okay, and Strike Eagle. That's it. Okay. Okay.
Oh no.
The F-15 Strike Eagle for the Apple II computer. So we'll watch this clip for just a little bit. Okay.
But like this, y'all youngsters would never understand. This was state of the art.
This was state of the art. Period.
1985.
no.
What the heck?
Wait, what year was this made?
12 years.
85.
Alive yet.
Oh.
One moment, please.
Oh no.
Okay, so I have to at least get to the part where you get to see the HUD display.
Oh my god.
Oh yes. Y'all youngsters.
It's like putting your fingers on the chalkboard right now.
Yes. Okay. So, but what you do need to understand is the amount of processing power available on that Apple II computer. Okay, compared to what you have today. Okay, the Apple II computer had a single processor, single core, single processor. Okay, so forget about multi-core. That just did not happen. Okay.
What about hyperthreading?
Hyperthreading? There's no such thing as hyperthreading.
Oh my goodness.
So it has one processor. The processor is an 8-bit processor as opposed to a 64-bit processor that we have now, which basically means every addition can only add 2 8-bit numbers instead of 2 64-bit numbers. Okay. The clock speed was 1 point something megahertz, and you heard it right. You heard me right. 1 megahertz. Not what you guys are familiar with, like, oh, I can overclock my XYZ processor to 4 gigahertz. Even in plain form, it is still running at 2.4 gigahertz. No, we are off by, what is the magnitude we are off by here? 1,000-fold, okay? Not even counting that, multiplier after the gigahertz, okay?
That's nice to see in
So
perspective.
you're talking about single core, single processor, single ALU, okay? Modern processors, even for one single core, you have multiple ALUs that can do computations all at the same time. And all the instructions, in modern processors, all the usual calculation thing, they can complete one addition per clock. So when you're talking about 2.4 gigahertz, you can complete basically 2.4 billion additions per second. These older processors cannot even match that. It would take about 6-7 clocks per instruction. So the penalty is huge, and yet they can still make this happen. Okay? And the reason why they can make this happen is they try to squeeze as much processing as they possibly can out of that poor 1 megahertz 8-bit processor that has a single core, a single ALU, and multiple clocks per instruction. Okay? And by the way, your 64-bit processors also has 16 registers. Okay? Guess how many this thing has? 1.
Oh my goodness.
The single register is also known as the accumulator.
Oh, no.
Okay? Everything else you have to do it with memory. You have to do all kinds of operations to get something from memory, do the calculations, store it back into memory, and stuff like that.
Can this play Minecraft?
No.
Okay.
You can probably implement an Apple II computer in Minecraft and have it being faster than the original hardware Apple II computer. I mean, I'm not even kidding. I mean, my watch has more processing power than this.
Turn this off.
Is it too painful?
I mean, it's still nice to imagine what 1,000 of this performance is. So that's nice how far we came, but
Yep.
The game is kind of wrong though. It's showing like Mach 8, Mach 9. We can't reach those speeds.
I don't think, is it Mach 6?
Yeah,
Maybe
it's
it's,
Mach 5, then Mach 8.
yeah.
And it's like it's bouncing back and forth. That's
Yeah, that's,
not quite
yeah, when I
precise.
played this game, it was on a monochrome computer. And you can probably tell it is really difficult to tell the sky from the ground. Because the only difference is the pixels are aligned slightly differently like this, but they look like the same because they're the same shade of gray on a monochrome computer. So you have to look at a fine line, where the pattern starts to stagger, then that's your line separating the sky from the ground. But after you have rotated it a few times, you can't tell anymore. Okay, but that brings back, why, we want to do something like this. Because instead of having multiplication, division, even those division by 2, we now just have addition, which is way faster compared to this when your processor doesn't give you multiplication that is done by hardware. Okay? So that's kind of interesting. And in many ways, it also relates to this little information sheet here. Because the Arduinos also make use of 8-bit processors. It runs a little bit faster than the Apple II. I think these run 16 megahertz. So we're still talking about megahertz here. But most instructions that do calculations are 1 clock per instruction. So they are actually quite a bit faster than an Apple II computer. There are also 32 general purpose registers and stuff like that. So when we are talking about a processor like this on the Arduino, we are talking about at least 50 to 100 times the processing power of the Apple II computer. Yep.
So you can run straight even on Arduino.
After emulation.
After emulation, okay.
After emulation, yes,
Run
and
Doom.
it would still be faster than running on an actual application computer. Yeah, but it doesn't have multiplication on the ALU. So the ALU can do addition and subtraction, but it doesn't do multiplication as an instruction. So when every time you want to do actual multiplication or division, it takes a long time. So why is that related to what we are talking about? I used to teach micromouse design at UC Davis. It's a class where people have to put together robots and do motion control and stuff like that. And as a part of the motion control, there's one equation that involved, calculating the square of something. It has to do with the speed versus the distance traveled of the robot. So it does involve, the calculation of squares. And if I use just, the usual equation in physics, the processor actually does not have enough processing power to do motion control. It just locks up and go like, nope, can't do this. But once I simplify the equations and turn multiplication into just addition, then suddenly we have all the processing powers left to do all kinds of stuff. So that is one reason why sometimes looking into optimizations like this can be very helpful, because if you can fit a less expensive processor into a product, like in an embedded application, your employer, whatever the manufacturer of the device is going to be very happy.
Oh, okay.
Because instead of sticking a, let's say, $8 processor, now they can put a 50-cent processor into the product. You are talking about increasing the profit margin by a great deal. Well, it depends on how much the device itself is, but these days we can put devices into just about anything. So, yeah, just to give you the context of why this is actually useful. So we got one more question, I think. Nope. Yeah, one more question. Just one more. So this question is asking, what is the closed form of this sigma notation? So let me magnify just a little bit more. The derivation is already in the answer. So this is what we are going after. We want to find the closed form of this particular sigma notation. And you can make the assumption that A is less than or equal to B. A is a natural number, B is a natural number, and I want you to derive your answer step by step. So without reading the actual answer, what are you going to do? Well, you have to kind of recall from this class, what we have talked about sigma notation, right? So you kind of have to know those techniques already. And this is why I said, even though this is why I said, you have to understand my proofs, because you are reapplying those steps in this particular question. Okay? So the first thing I did is to, okay, what did I do from here to here? Okay, from here to here. What did I do? You can see how I is moving in a, it's still the same number of iterations, but the starting point and the ending points are now different, right? It started from A before, it ends at B. Now it starts from A minus A, which we also know as 0, and it ends at B minus A. But when I make that adjustment to I need to make adjustments to the term that we are summing over. So we have to say, oh, since the index I is now A less than what it used to be, but it has the same number of iterations, we have to add the A here to cancel out that effect. Is that okay? So what did I do from the second line to the third line? Okay, we just simplified the 0, A minus A to become 0. What about here to here? I break it up, right? So when you're dealing with a sigma notation, if the expression being summed is an addition, you can always break it apart in any way you want. Okay? So I just break apart the I to be on one side, and then the 1 plus A on the other side. The reason why 1 plus A is on the other side is 1 does not depend on I, A does not depend on I either. So 1 plus A is really just a constant. So the constant goes on one side. So this side, do you notice anything about this side?
It's basically just multiplying it by b minus a.
It's the sigma notation that we already know, okay? So that becomes b minus a times b minus a plus 1, the whole thing divided by 2, because this is exactly the same kind of sigma that we have gone through already. What about the other side? What about this sigma? How did I lose the sigma altogether? Because it's just multiplication. Because 1 plus a is a constant. How many times am I adding that to itself? It is b minus a plus 1 times, because we start counting from 0. So that's why it is b minus a plus 1, which accounts for how many times we have to go through the sigma. And then each term of the sigma is just 1 plus a, which is a constant. It does not depend on I. So this is the final answer. So the technique of dealing with the sigma notation is important. Yep.
Do you have kind of a general rule for how simplified the answer should be?
As long as you get rid of the sigma, it is still quote unquote in closed form. So even though you may be able to, I see what you mean. So you can simplify certain things out of it because b minus a plus 1 is also here, but that's okay. Either way, this is already getting rid of the sigma notation, so it's already in closed form. So the question did not ask for the simplest closed form; it just asked for a closed form.
Could you separate it before you start changing the start and end point? Like for example, you have from A to B of 1, and then from A to B of I, and then do the separation. To change it, because then you'll just have a multiple of B to from B from B.
There are other ways to get to the same result.
I think you can do
That is correct. Yep.
Just breaking up or indexing each separate sigma.
Yep.
Which just doesn't matter.
Yep. So there are multiple ways to get to the solution. This is just one way to do it. Yep.
Just math.
It is all math. Yes.
It's great math. Okay.
I'm just kind of surprised that nobody has brought up the point. It's like, but this is a computer science class. What is this math doing in a computer science
Well,
class?
that's what computer science is, ain't it, man?
It is math.
It is computer science is math.
Yeah, because
Yep.
what happened was when I went to go do my registry, it didn't even have computer science on there, it just had math.
Mm-hmm.
Like, well, I guess I'm a math major now, shoot.
Mm-hmm. All right. So are we good so far with this particular practice exam?
Can I come and talk to you in the office hours?
Yep, you can.
Thank you. And then I'll be good.
Okay.
What the heck is that, man?
I think it's the same thing.
Just making sure, man. Don't be throwing no
It's just
balls.
expanding the series to illustrate, how we can, how we can break it up. Yeah. So it's just an explanation.
That just is like in Final Fantasy books, you fight Sephiroth, and now all of a sudden you got to fight Kefka, and all your health gone. Nobody knows Final Fantasy.
Not anymore.
Okay.
Okay, so here's the other one. We don't have enough time to do this, but the solution is already in the quote-unquote the answered version. So if you want to get, practice a little bit more, you can try to do it first by yourself without looking at the solution, and then you can look at the answer to look at the solution. Yep.
So is Aleph Null the last section that's going to be on the midterm?
Well, we technically covered relations already, and so relations can be in it as well.
But is there any? I don't see any relations on the practice.
Well, that's because last year I did not even talk about relations.
Well, okay. Well,
Yep.
then would you go over relations more in next class? Could you give us some practice questions for relations?
This one might have it. Just give me a second to load the questions.
Probably this.
Yep. Yeah.
I know we've kind of gone over this, but we haven't really done a whole lot of work with it. But I noticed on some of the past exams, there's a lot of proof by contradiction questions. We're in the paper to kind of prove and then come up with that. Is that going to be
There won't be any proof questions in exam 1. Yep. But relation is on it. So this one is a relation. R is, so there's a relation question here. And this is also a relation question here. So if you look at the,
not like that, right?
huh?
Nothing like Q6, right? Could there be something like Q6?
Q6.
You're right there. Question 6.
Okay, prove that the following theorem. So no questions like that in, because this class has not talked about compound functions.
Are the answers to the practice questions are up there?
Yes. So the answers are in the same question, but with a dash answered. So the answers are there. So that gives you, like one more practice test. It's just that, I don't have time to go over that in class. But if you look at this one, yeah, my computer's kind of slow to load all of this stuff. But the answers are all, they're basically here with the explanations and whatnot. Okay? So I'll see you guys next Wednesday. You're more than welcome to come on Monday. I won't be here.
Okay, cool.
Go ahead. Well, I think I should say.
So I have a couple questions.
Mm-hmm.